Because the current is amplified, we have a current here with GM pi, we can use the NPN transistor as an amplifier. So this is about the AC behavior again. Just first mention the input and output resistances. The input resistance from, if we are looking at from here to the base, that means we're looking at here. So from here, base to emitter, we see the R pi. So your input resistance would be R pi. So output resistance can be defined from two places. One, if you're looking from the collector, that's we would see only the RO. If you're looking from the emitter though, what we would see is about 1 over GM. So let's keep them in mind. Now we're going to look at two configurations. So common emitter configurations. One is the regular common emitter where your input is at the V in, your output is at the collector. You have a resistor here. So we talked about the R in is the same as up in R pi. Your R out in this case, because RC is going to be between collector and ground, because in AC we'll take this in ground, you will have that RC right here. So this RC would be right here. So it's going to be in parallel. RO in parallel with RC. And your gain is V out over V in will be given as negative GM, that's your current gain, the current capability of the transistor times your output resistance. So negative GM times the output resistance. This is for the common emitter, with a simple common emitter. If you had the similar, but this time a emitter degeneration, where you have a resistor at the emitter, you still have your input and output. In this case, your input resistance, because now this RE is gonna come here as a resistor, their input resistance would change. It would be R pi, not just plus RE, because we have the current gain here, the effect coming from here, the current is adding here, it's going to be beta plus 1 times RE. So that is your input resistance. Your output resistance would be the RC parallel with RO times 1 plus GM RE in parallel with R pi. So you have the RO in parallel with RC times, if it was only this one for the common emitter simple, now you are adding this term. So it is, you're basically multiplying it with 1 plus GM RE in parallel with R pi. And your gain for the circuit would be given as negative GM RC in parallel with RO divided by 1 plus GM RE.